4 billion miles from where you're sitting right now, a telescope built to look at galaxies that formed billions of years ago quietly turned around, pointed backward into our own solar system, and stared at a tiny, frozen world that most astronomers had written off as finished business. And what it found broke a rule that scientists were confident had held for decades. Not a small correction, not a footnote in a research paper, a result so strange that the team that found it spent months trying to prove their own instrument was wrong before they accepted what they were actually looking at. Stick with me, because by the end of this, you're going to understand why a machine built to study the first light of the universe just rewrote what we thought we knew about the coldest, strangest world in our own cosmic backyard. And if you want more stories like this, one where I only tell you what was actually published and actually measured, hit subscribe now, because there's more coming out of the outer solar system that hasn't even made headlines yet. Let's start with why anyone even bothered pointing a multi-billion-dollar telescope at Pluto in the first place, because on paper, it shouldn't have been a priority at all. Pluto was discovered in 1930 by a young researcher named Clyde Tombaugh, working out of a small observatory in Arizona, comparing photographic plates night after night until a single point of light shifted position against the background stars. For most of the 20th century, that was basically all we had, a dot. Astronomers could track its orbit with reasonable precision, but its surface, its atmosphere, even its true size, stayed locked behind a wall of distance no telescope on Earth could punch through. Then in 2006, the International Astronomical Union voted to reclassify Pluto as a dwarf planet, and for a lot of people, that felt like the final word. Case closed. Small, distant, unimportant. Then in July of 2015, after a 9.5-year journey across the solar system, NASA's New Horizons spacecraft screened past Pluto at more than 30,000 miles an hour. It had one shot, no orbit, no second pass, just a few minutes to gather everything it possibly could before continuing on into the darkness of the Kuiper Belt forever. What it sent back rewired the picture completely. A massive, pale, heart-shaped plain, mountains of solid water ice rising over 10,000 feet, frozen so hard it behaves more like bedrock than anything you'd recognize as ice, fields of nitrogen ice that appeared to be slowly churning, like something underneath was still active, and layer after layer of blue haze rising hundreds of miles above the surface. Pluto didn't look dead. It looked like a world still in the middle of becoming something. But here's the problem. New Horizons got one look, and then it kept flying. Whatever it missed on that single pass was going to stay a mystery, possibly for generations, because there is no funded mission to go back. No lander, no orbiter, nothing on the books. A return trip would take the better part of a decade just in travel time, and outer solar system missions have never been an easy sell against cheaper, faster targets closer to home. So for years, all we had was a single postcard from 2015 and a pile of unanswered questions about what was actually happening on that surface, in that atmosphere, right now. This is where the James Webb Space Telescope enters the story, and it's worth understanding exactly why Webb can do something New Horizons never could, because it's not just a better camera. New Horizons flew past and took a photograph. Webb does something closer to reading Pluto's actual chemistry from a distance of 4 billion miles, without ever leaving Earth's orbit. It breaks apart the faint light reflecting off Pluto into individual wavelengths, and in doing that, it can tell researchers what molecules are present, how warm different layers of the atmosphere actually are, and how all of that is changing over time. No spacecraft required. Just starlight bounced off a dwarf planet and decoded. Except there was a problem standing in the way, and it's one most people have never heard about. Pluto has a large moon called Charon, and from Webb's point of view, the two objects sit so close together in the sky that separating their individual heat signatures had been practically impossible with earlier telescopes. Researchers had tried before Webb even launched to detect specific signals coming from Pluto's atmosphere, and they kept coming up empty, not because the signal wasn't there, but because their instruments simply couldn't tell how much of the detected warmth was coming from Pluto itself, and how much was bleeding in from Charon sitting right next door. It took Webb's much larger mirror and far more sensitive infrared instruments to finally solve that specific problem, cleanly isolating Pluto's own thermal signature for the first time in history. Once that calibration was locked in around 2022, Webb turned its full attention toward Pluto, and what came back over the following years wasn't just a prettier picture, it was closer to a full diagnosis. And one part of that diagnosis in particular is the reason we're talking about this today. Back in 2017, a planetary scientist named Shi Zhang, working at the University of California, Santa Cruz, put forward an idea that sounded almost backwards at the time. On Saturn's moon, Titan, atmospheric haze traps heat and warms the surface below it, the same way a greenhouse works. Zhang argued that Pluto's haze might be doing the exact opposite. Instead of trapping heat, he proposed that the haze particles absorb sunlight during the day and then radiate that energy straight back out into space as infrared heat, faster than Pluto's incredibly thin atmosphere could ever hold onto it. In other words, the haze wouldn't be acting like a blanket. It would be acting like a radiator, actively bleeding heat away from a world that barely had any heat to spare in the first place. At the time, a lot of Zhang's peers found this hard to swallow, and there was no instrument sensitive enough to actually go out and test it. That changed once Webb's mid-infrared instrument became available and capable of cleanly separating Pluto's faint thermal signal from Charon's, something no previous telescope had ever managed. A team led by astronomer Tanguy Bertrand at the Paris Observatory used that instrument to measure Pluto's atmosphere directly, and the results, published in the journal Nature Astronomy in June of 2025, confirmed almost exactly what Zhang had predicted 8 years earlier. Pluto's upper atmosphere really is being actively cooled by the very haze particles suspended within it, and the measured temperature came out roughly 30 degrees Fahrenheit colder than earlier models had expected. Not a rounding error, a genuine miss corrected by direct observation instead of theory. It helps to understand just how difficult that specific measurement actually was, because this wasn't a quick glance through an eyepiece. Bertrand's team had to work with a signal so faint that earlier attempts using ground-based telescopes and even earlier space missions simply couldn't extract anything usable from the noise. Charon sits close enough to Pluto in Webb's field of view that separating the two thermal signatures required extremely precise calibration of the telescope's mid-infrared instrument, built originally with distant galaxies in mind, not a dim, tiny world 4 billion miles away. The team had to model exactly how much of the detected heat belonged to Charon and subtract it cleanly, leaving behind a pure reading of Pluto's own atmosphere. Get that calibration even slightly wrong, and the entire result collapses into noise. Get it right, and you end up with the first clean confirmation of an idea that had sat untested for the better part of a decade. Sit with that for a second, because this is the part that shouldn't be possible, according to how we normally think about distance and cold. Pluto isn't simply cold because it's far from the sun. Every world out there is cold because it's far from the sun. That part is expected. What Webb confirmed is that Pluto is actively refrigerating itself. Its own sky is doing extra work to make it colder than sunlight alone would ever explain. Researchers are now describing this as a genuinely new kind of climate, one that behaves differently from every other atmosphere we've studied anywhere in the solar system. And scientists are still working out how far the consequences of that discovery reach, including whether similar haze layers might be quietly shaping the climate of other distant hazy worlds like Neptune's moon Triton, or even hinting at what Earth's own atmosphere may have looked like billions of years ago, long before oxygen ever built up in our skies. If a discovery like that, something confirmed through real published research instead of exaggerated headlines, is the kind of thing you want more of, drop a like on this video right now. It genuinely helps this content reach more people who'd get something out of it. Now here's the second piece of what Webb picked up, and it's quieter than the haze story, but honestly just as strange once you actually sit with it. Even the extremely faint trickle of sunlight that reaches Pluto is enough to break apart methane molecules high up in its atmosphere. Those broken fragments don't just vanish, they recombine into heavier compounds, forming a slow chemical cascade that eventually produces reddish-brown particles called tholins, which drift downward and settle onto the surface below. New Horizons caught early traces of this process back in 2015, but Webb's ongoing observations have helped refine exactly how it unfolds over time. And here's the detail that tends to stop people in their tracks. Tholins belong to the same broad family of organic molecules that some scientists believe may have once rained down onto early Earth, potentially contributing raw material for the kind of chemistry that eventually led to life here. On Pluto, that same basic process has apparently been running for roughly 4 billion years. A slow, continuous snowfall of biological building blocks, landing on a surface that is simply too frozen for any of it to ever spark into something alive. To really understand how extreme that cold actually is, look at the raw numbers Webb helped confirm. Sunlight reaching Pluto is roughly 1,000 times fainter than sunlight reaching Earth, meaning even high noon out there would look closer to a heavy twilight here. Surface temperatures generally sit somewhere between about negative 387 and negative 369 degrees Fahrenheit. That's more than 250 degrees colder than the coldest temperature ever recorded anywhere on Earth. At those kinds of temperatures, nitrogen, the same gas that makes up most of the air you're breathing right now, freezes completely solid. The atmosphere you're sitting in as you listen to this would, on Pluto, simply become part of the frozen landscape. Scientists care about this beyond just how strange it sounds, because researchers studying the origins of life on Earth have long debated where the first organic building blocks actually came from. Whether they formed here on the early planet itself, or whether some of that raw material arrived from space, carried in by comets, asteroids, or slow chemical processes happening in distant icy environments, similar to what Webb has now confirmed is happening on Pluto right now. Studying a real, ongoing example of that chemistry running continuously for billions of years on a nearby world gives researchers something they otherwise could never have: an active natural laboratory for a process that, on Earth, finished playing out and left behind only indirect evidence billions of years ago. And then there's the discovery that involves Pluto's largest companion, a battered ice moon named Charon, roughly 750 miles across. For years, researchers had noticed something odd about Charon. Most of its surface is fairly unremarkable water ice, ancient and heavily cratered, except at its poles, which are stained a deep, unmistakable reddish brown, darker than anything else visible on the moon. Scientists suspected a connection between that coloring and material escaping from Pluto's atmosphere, but they lacked the tools to confirm it directly until Webb. Here's the mechanism, and it's tied closely to Charon's extremely slow, extremely long seasons. Because of the way Charon is tilted as it orbits alongside Pluto, its northern polar region spends multiple decades in complete darkness at a time, with no sunlight reaching it at all during that stretch. That makes the pole an extremely effective cold trap, a place where escaping methane molecules drift in, freeze solid onto the surface simply because there's no warmth to keep them as gas, and then sit there accumulating for years before sunlight finally returns to that part of the moon. Once sunlight does return, it doesn't melt that frozen methane away. Instead, ultraviolet radiation and cosmic rays break the frozen molecules apart and reassemble the fragments into heavier, more complex reddish compounds, essentially locking in that dark coloring permanently rather than letting it evaporate back into space. In effect, two worlds locked together in a slow, ongoing exchange of atmosphere and color that's apparently been running quietly since long before either one had a name. Charon had one more surprise waiting too. In October of 2024, a team led by researcher Sylvia Protopapa at the Southwest Research Institute used Webb data to confirm the presence of both carbon dioxide, the same gas leaving your lungs with every breath, and hydrogen peroxide, the same compound sometimes used to disinfect a wound frozen directly onto Charon's surface. According to the published research, the carbon dioxide most likely originated from underground material exposed by impact craters, while the hydrogen peroxide appears to have formed through years of radiation striking Charon's water ice and rearranging it into something new. That specific combination of frozen chemicals had never been confirmed on Charon before, adding another layer to a moon that keeps turning out to be far more chemically complex than its plain icy appearance would ever suggest. If you found this as strange and fascinating as I did while putting this together, drop a comment letting me know. It genuinely helps me figure out what to cover next. Now picture, for just a moment, what it would actually feel like to stand where Webb has been quietly studying this whole time, because the details Webb helped confirm are almost hard to imagine otherwise. The sun would still be visible, but only as an intensely bright point of light, smaller than a pinhead held at arm's length, giving off no real warmth and no meaningful glare. You could look directly at it without any discomfort at all. The sky around it would sit in a permanent grayish-blue gloom, thick with the very haze Webb just confirmed is actively cooling the world beneath it. Never fully day, never fully night, just an unchanging dimness. The ground beneath your feet wouldn't behave anything like ice does here on Earth. At nearly 400 degrees below zero, water ice stops being slippery and instead behaves closer to solid rock, hard enough to ring almost like metal if struck. And overhead, fixed permanently in the same spot in the sky, Charon would hang there, unmoving. The two worlds are close enough in size that they don't orbit each other the way Earth orbits its own moon. Instead, they orbit a shared point in empty space between them, locked so tightly that each one always shows exactly the same face to the other. This connects to something Webb's data has kept feeding into, a debate scientists have been having for years about whether Pluto is hiding a liquid ocean roughly 100 miles beneath its icy surface, kept in a liquid state by the slow radioactive decay of elements inside its rocky core. The evidence isn't a photograph. It's a pattern. Cracks and ridges across the surface line up in ways that fit what you'd expect from a subsurface layer of liquid water shifting slowly beneath the crust, and that famous pale heart-shaped plane sits directly above what appears to be a positive gravity anomaly, a spot where something denser than the surrounding ice may be concentrated underneath. Scientists find this genuinely compelling because similar hidden oceans are already strongly suspected beneath the icy surfaces of Europa, one of Jupiter's large moons, and Enceladus, one of Saturn's smaller moons. If a body as small and as cold as Pluto turns out to be hiding something similar, it would suggest that buried oceans might be a far more common feature of icy worlds throughout the outer solar system than scientists previously assumed. What makes this even more remarkable is that none of it required a single new spacecraft launch. Webb wasn't built for Pluto. It was designed primarily to look at the earliest galaxies in the universe, tens of billions of light years away, and yet the same instruments capable of that kind of depth turned out to be sensitive enough to isolate a whisper of heat coming off a dwarf planet in our own solar system's backyard. That's part of why this result caught so many researchers off guard. Nobody built Webb to solve Pluto's haze mystery. It happened to be capable of it anyway, almost as a byproduct of being built to see farther than any telescope before it. Right now, there's no way to confirm any of this directly, and that's the part that makes Webb's ongoing work so important. There's currently no funded mission planning to send a probe back to Pluto. No lander, no orbiter on the books, largely because a return journey alone would take the better part of a decade. And outer solar system exploration has rarely been treated as a funding priority against missions closer to home that can return results within just a few years. For the time being, Webb remains our only working tool, quietly checking back in every few months whenever Pluto swings back into its field of view, adding another data point each time, and almost always making the overall picture stranger than it was before. Here's the detail that tends to stick with people longest after they hear this whole story. Pluto isn't unique simply because of its location. It sits inside the Kuiper Belt, a vast ring of icy debris beyond the orbit of Neptune, home to hundreds of thousands of objects wider than 60 miles, along with an estimated trillion or more comets. A handful of other bodies out there, including Eris and Makemake, come reasonably close to Pluto's size. And unlike the much more familiar asteroid belt between Mars and Jupiter, which has been mapped in fairly close detail, the Kuiper Belt remains almost entirely unexplored territory. Only one spacecraft, New Horizons, has ever ventured deep enough into that region to closely photograph any of its larger residents. And even that mission only managed close flybys of 2 objects out of the hundreds of thousands of similarly sized worlds believed to exist out there. If Pluto is genuinely cooling its own sky, slowly bleeding its atmosphere onto a companion moon, and possibly hiding a liquid ocean beneath a shell of solid ice, there's no obvious reason to assume it's the only object out there doing anything like this. It's simply the one close enough and bright enough for Webb's current instruments to study in real detail. Nearly everything else scattered across that same enormous region of space remains almost entirely unobserved. So what does this actually add up to? Pluto was never really the dead end of the solar system that a single vote back in 2006 made it seem like. Webb just confirmed that it's running an atmosphere that shouldn't be able to cool itself the way it does, feeding a chemical process that mirrors the raw ingredients of life, and sitting next to a moon that's been quietly absorbing its escaping atmosphere for billions of years. Out past the orbit of Neptune in the cold and the dark, there are trillions of other worlds we've barely glanced at, let alone studied closely. And if one small, frozen, formerly dismissed dwarf planet was hiding this much complexity underneath its surface, it's genuinely worth wondering what all of those other distant worlds might be hiding too. If stories like this, grounded in real published research instead of exaggerated headlines, are what you want more of, subscribe to this channel and turn on notifications. Because Webb is still pointing back at Pluto every few months, and there's a real chance the next round of data adds another genuinely strange piece to this puzzle. Thanks for watching, and I'll see you in the next one.